moving as fast as you can because the bar forces is just the input of my subject. So when you say input, di gud siya ingon nga maura gud ato ang i-perform nga kuan process. Usa ra siya ka process. So daghan tag process nga gamiton. Kini na. So that is only one input. May kuan ani nga sa theory. So sa una gipa-compute mo bar force karon application na gud siya. Asa man ni no in the design you need to specify everything sa bending, sa shear o sa deflection. So diri na ato ang kuanon. We have to compare the actual deflection sa allowable deflection. It should be ang imuhang actual deflection less than siya sa allowable deflection. Okay. So again, we have two types of truss. That is, we have roof truss and we also have bridge. Okay, we have bridge truss. Okay, so ang sa roof truss, the load of your roofing, transfer na siya sa imuhang okay, ang roof load nimo, imong gi-transfer siya sa imuhang purlins. Kanang blue diha, purlins na siya. Kanang black diha ang akong gishidan, this the black one. If you get the tributary area for the load, no, kaning imuhang load sa imuhang purlins, you take one half sa imuhang span sa imuhang sa tawagan ni man spacing. No, that is not the span. The spacing, one half of the spacing of your purlins, monitom akong gi-shade which is maupod ni diri. Mo na siya ipagkuha sa tributary area for your loading, for your spacing. That is one half, no? Kung equal imuhang spacing, so equal rap na. So ang one half, equal imong spacing sa post, tunga sa pikas, tunga po sa pikas, still ang imuhang spacing, this same rapod sa imuhang width sa imuhang pag-divide. Okay, so this will be the, you can have S1 and this is your S2 purlins. This is the bay, no? This is the bay. Bay is the spacing between trusses. The span, that is the length of your truss. Okay, sa na to, no? Again, ang imong roof load, imong i-transfer sa imong purlins. Ang purlins, iya i-transfer sa imong top chord. Ang nimo sa imuhang truss, including the self-weight of the truss, will transfer to the column. Then for the column, ang load, kaning akong drawing column raman. Pero actually, in the actual, ang load nimo sa truss, load sa imong roofing, transfer purlins, ang purlins, i-transfer nimo sa truss, ang truss nga load, i-transfer nimo sa beam, i-transfer nimo sa girder, then girder, transfer column, transfer sa footing. So, there is a load transfer of the load from the top, no, of your member down to footing. Okay, so mao ni siya. Then ang imuhang truss, you have bottom chord sa ubos. So sa top chord, unsa mang mga load ang imuhang top chord? Ang top chord nimo can be wind load, snow load, weight of the roofing, self-weight sa purlins, live load, no? Those are that load of the top chord. Sa imong bottom chord, same load, kaning sa mga mechanical, MEP, mechanical o electrical nga mga force. So, tanan nga mga loads nga imuhang makitaan, imo nang ipa-apply sa top chord, bottom chord. Then, you also have the diagonal member. Then, you also have the the vertical member. So kaning sa tunga gitawag siya king post. So mao na siya mga kuan sa truss. Okay. This one is bridge truss. So pwede nun ana imong truss. This one also you have another truss. It is also Warren truss. You also have Pratt truss. You also have Finks. So daghan ang mga klase truss pero di na kay ko mo go deeper ana because I know discuss na sa previous nga subject. Okay. So again, for the determinacy of trusses, this is just a review. So if you have the equation plus R is equal to 2J, so it is statically determinate truss. If B plus R is greater than 2J, your truss is statically indeterminate. Then B plus R less than 2J, that truss is internally unstable. What do you mean by B, R, and J? B is number of bars. The R is the number of external reactions. You have R is equal to 2 if for each reactions hinge or pin. Then 1 for each ruler or rocker. Then the number of joints. So for the degree of determinacy, that is B plus R minus 2J.
Excuse me, ma'am.
So,
Murag tapot ka, ma'am.
Tapod. Screenshot na lang ko ninyo ha. Okay, so again, the bridge, no? Truss. Then you have the Warren truss. You also have the Pratt truss. Again, then you also have Fink truss. So, daghan mo, I know, daghan pa mo nabalaan. Who truss? Who truss. So, di na kay kumug deeper ana. Okay, so this is the criteria for the degree of the determinacy of the truss. So, ikuan lang na ninyo. So, we have that one. Then, for the degree of determinacy, okay, we have also B plus minus 2J. So, that is the formula. So, before solving the truss, you have to determine the degree of determinacy. If it is determinate, so you have to analyze it for determinate truss. If it is indeterminate, so you have to analyze it as determinate truss. So when you say determinate truss class, you can solve it using static equilibrium equations. So you can solve all the reactions using the static equilibrium equations, then compute the bar forces. However, statically indeterminate beams, I mean indeterminate truss, the same siya sa beam na there is a redundant reaction or a redundant member na ni-exist anang imuhang truss. So you have to choose if it is indeterminate to the first degree. So na kay usa nga excess. So maybe you can choose it is either support ang imuhang kwaon or member ang imuhang kwaon to make the truss determinate, be a determinate truss. Kung na kay duwa ka degree of kuan indeterminacy, so maybe usa ka member ang imuhang kwaon, the other one usa ka support to make it determinate truss. Okay, so we have to solve the deflection. So mo ni ato ang concern, the deflection of the truss. So di concern ako kaayo ang bar forces because bar forces is only one input to my subject. Ang atong concern is to determine the deflection. So it is simply the SULA. So I have this one, SULA, that is summation of SULAE. So ang SULA, S is stress in the member, then L is the length of the member, then A is the cross-sectional area of the member. So truss man atong gisgut. So the truss, not all the time, or not all the members can be kuan. the cross-sectional area the same. Lain-lain ang imong cross-sectional area. For example, for the roof truss, you have the top chord, lahi imong cross-section. For the bottom chord, lahi. Then, lahi pod imong vertical, lahi pod imong diagonal. But for the modulus of elasticity, this refers to the type of the material you are going to use. It can be wood, timber, or steel. So, the same ra gud na siya, no? Pero siguro na ay times nga kahoy imong gamiton then or steel then imuhang vertical member kahoy or kahoy imuhang bottom chord top chord na imuhang kuan vertical o diagonal steel. Wala man siguro. Kung kahoy or nabantayan. Okay, then the same with this superposition method or Castigliano's theorem, we have to apply 1 unit vertical or 1 vertical unit load. So asa to dapit pangita ang deflection, you have to use you have to put a 1 unit load. So unitless na siya. Then the deflection formula is summation of SUL divided by AE. So that is the formula. Oh.
Excuse me, ma'am. Murag tapos na pod, ma'am. Nalam this degree of indeterminacy, ma'am.
Ganihar ako gaya, ako nung nag-ingon. Kayo na ko.
Sorry kay ma'am. Katong sa sola-sola.
Ano mo, ani? Okay, so that is SUL over AE. Ang stress nga S, muna siya inyong bar forces due to actual load. Ang U is the unit load. That is unit virtual load. So, okay, mauna ato ang formula for the deflection and only for determinate beam. So, kung ang inyong thrust, no, for the determinate thrust. So, that is the deflection for the determinate thrust. So, importante, sa inyong solution sa thrust, i-identify ninyo sa siya. Determinate ba siya or indeterminate? Kay lahi man ang analysis for indeterminate, lahi pong analysis for determinate. So the same po sa atong beam, lahi ang analysis sa determinate beam, lahi po sa indeterminate beam. Okay, so this is simple, no? Sola, ako ra gud ning gikuha. Ako memorize on sola ra jud ni kay para mas masayo na pag memorize sa formula. Okay, so I have here an example. So, that is a simple thrust lang for you to understand sa deflection. So, kung tagaan mo og taas-taas or kung dako nga kuan, pila ka span nga thrust, okay ra pod as long as you know the basic. Then, inyong lang is you have to know how to determine the bar forces. So, as fast as you can. No? So, na-learn ako ang ba sa trust, you can use method of sections, dayon methods of joints, di ba? So, inyo atong method of sections mo, then ikuha na po ninyo each joint. Not all the trust nga inyo siyang gamaan o methods of joints o method of section. Katurang paminaw nimo nga daghan kaayo siya consider nga mga sa imuhang joints diha daghan ka i-compute nga mga component. Katura ang imuhang methods of section. But for those joint nga diretso ra nimo siya, you can directly solve it without even showing the method of joints. So masolve lang na ninyo. So again, I presented here unsa maning mga bar forces, no? So from actual load, so again, this one, that is the direction of your wind sa windward side. So asa tong direction sa imong wind, katong mahapak diretso sa imong wind, mo na siya windward. So ang force sa imong wind ana is full force. Sa katong pikas na side is the leeward side. So that is the leeward side. So ang imong course, the only one half of the wind. Okay. Kanang W, daghan pa na siya kuan, asa na siya gikan. So it can be wind load, roofing load, rain load, live load. Diba? Then for the bottom chord, you can have the ceiling load, the mechanical load, the electrical, mga fixtures. Okay, then daghan pa kag mga pangmuliha nga mga load. So those are the load. Then sa imuhang load, ang imong kuan, ang imuhang ceiling load, roofing load, ga-act siya, nag-act siya normal, no? Ano, ang wind load is ga-act siya og normal sa imuhang roofing. Ang imuhang roofing load, so it can be, kuan man na siya. So, ang pag-drawing na ako. So, maybe this. So, muna siya imuhang wind load. So, ang imuhang with sa roofing, with sa rain load, okay, with sa purlins, sa kuan. So, diha nagagikan. You have to determine also the component, the X and Y component of the, so this is WR or WX. WX, no? This is your WY. Okay, WY is your wind load. Di ba, namo sa steel, unsay mga forces sa imuhang normal to your truss? After sa beam, sa steel ninyo, truss naman, I hope kahibalo mo kuha unsa na mga load. You have the ceiling load, you have the purlins, you have the roofing, the rain load. So, those are the loads. Basta siya yung mga loads class, then you have to combine. Mo man na siya. You have 1.2 dead load o 1.6 load. Pwede po na imuhang kung nabay combination ang dead load o wind load or live load plus wind load. So, inyo ng combination, ang maximum nga combination mo to inyong iton. So, mo na inyong ibutang diri. That is kilonewton. Inyo nang into kilonewton. Okay, that is kilonewton per meter. Convert na siya into kilonewton. Kung saan pagtana, so kato gani ha, take kag one half. Okay, one half imong kuan is okay, kilonewton per meter. Okay, kani nga length imong paon, no? Imuhang i-multiply para may mo siyang kilonewton. Okay, so this is the tributary area of the load. Kay siya, that is W. So that is kilonewton per meter. Multiplyan nimo siya meter ani. So ang makuha nimo is nalaman kilonewton. So mo na ni dire P na siya. Okay? Then, forces mo, negative compression, positive tension, sunod ana ang kuan. So, pag, di ba, kung compression side, dako ang imong compression, this is your beam, this is your timber albi. For example, kahoy imong gigamit for your truss. So you need to determine the dimension. So mag-assume mo dimension. For example, 50 by 50 mm. So inyo nang i-design, kinahanglan mo pasar siya sa bending, shear, and deflection. So mo pasar siya, sumao na siya inyong conclusion niya for that diagonal member or for the top chord and for the bottom chord, providing mao na siya actual load sa imuhang truss, sa imuhang member. Mo na siya imuhang dimension sa imuhang members. Mo na siya gagikan, no? Kana mo siyang dimension. That is for shear and for bending. And now, for deflection na pod mo. So, kato na po area, 50 by 50. So, makapasar ba siya sa deflection? Okay? Ana. So, kung mapasar siya sa deflection, pasar siya kuan. Okay. Okay, again, we have that one. So, the material is 150 GPa. Then, vertical deflection at joint B. So, itong kwaon ang vertical deflection at joint B. So, again, we compute the determinacy of the beam. So, we have here that, we compute the degree of indeterminacy of the truss. So, we found out that the truss is statically determinate. So, next is to compute the stress due to actual load. So, yung mga actual load, we have 60 kilonewton and we have 100 kilonewton. So, again, we need to determine the length of your truss, the length of your member. So, we have there 6 for AB. Butangan unsay mga ngalan sa imuhang joint. So, you have A, B, C, like that. Then, you have 6 meters sa AB, 6 meters for BC. Then, the height of your truss is 4 meters. So, you need to compute also the diagonal length. So, that is 2 square root of 13. So, that is equal to 2 square root of 13. That is 7.211. Okay, so, next is to you take moment, summation of moment at the reaction. So, either moment ka sa A or moment ka sa B. So, kwaon lang nimo ang mga reaction. So, naana. Kabalo naman mo ani because you know how to do the bar force. So, again, naana tayo reaction. Then, ayaw mo pag aning sa moment sa C class, inyo ikuan. Summation is vertical, dayon mo ayaw, kay naay possibility nga masayop mo di sa inyong reaction. Di na ninyo ma-check inyong solution. So, ayaw mo. You have to i-check ninyo na, no? So, unsaon man pag-check, i-check ninyo, summation forces vertical equal to 0. So, again, summation vertical is equal to 0. So, okay siya. Sa X pod ninyo, kay ang imuhang truss na siya horizontal load. So, ang imong sa A is also equal to 60. So, okay, so you have 60. Then, i-substitute ng imuhang function. So, sa A is 30. Sa C is 70 kilonewton. So, you have to determine directly from that one. So, I hope kabalo mo ani nga solution to solve it as fast as you can. I learned this one during practice before. So, tan-awon nimo ng kada joint, imong inspect ng kada joint, imong tan-awon asa ka pwede makakuha. So, in case at joint A, dili ko makakuha directly sa x-axis. So, dili ko kakuha sa akong x-axis sa joint A, di ko kakuha sa akong x-axis because na ako'y x-axis po sa imuhang joint sa imuhang member AB. So, pwede, ang imong A is naman kay member AD o member AB. So, sa axis, duwa ang imuhang anon. Dito ka mo tanaw sa usa ka anon. So, ang imong anon is sa vertical na side. Sa vertical component of member AD. You have the vertical component. So, the vertical component of AD is 30. Then, I have to determine the x component of member AD. So, I have negative 45. So, yun sa naku na pag negative 30. So, negative man, you have to take note the sign. So, negative 30, 6 divided by 4. So, asa to na ako, asa tong component akong ganahan ko akong, mo akong i-multiply, i-divide na ako component asa ko dapit ang iyahang length sa component nga katong known value. So, my known value is 30. So, I need to get the x component of member AD. So, 30 times 6 divided by 4. Divided by 4. So, I get 45. So, that's the sign is negative. Then, negative 45, ganahan kumukuha sa ako ang AD. So, I multiply it to square root of 13 divided by 6. So, that's why I get negative 15 square root 13. So, I have to balance. So, sa joint A, akong gi-balance. So, akong joint A, ang x component sa imong member AD, para ma-equal siya sa component sa imuhang AB. So, 65 plus napay 60. So, that's 60 plus 45. So, compression siya, no? Ang mo balance ana is 105. That is tension. So, 0 na akong 20. Okay, next is dire ko sa B. So, balance ako 105 nga tension. 105 po ang mo balance sa BD. No, sa BD na pod nga kuan member. So, tension na 105. Okay. Then, for 100, pwede ka, okay na, 100. So, pwede ka dire na pod sa joint D na pod, mutanaw ka sa joint D. Unsa may unknown value nimo, ang unknown value nimo sa joint D is the member, the X component or the Y component of member DC. So, again, pwede na ninyo panon ang Y component ana. So, kung tan-awon nimo ni Y component sa AB, AD, no, AD o Y component sa imong vertical member nga BD. So, that is 100. So, that is away, no? Away. Okay, 100 minus tension man imong 100. So, minus siya aning 15 square root of 10. So, pila man ng 15, okay, 15 square root of 13. So, that is 54. Sakto ba? 54 negative, negative. This is negative 70 man eh. Sure ka? Negative 70. Sorry. Sayop akong pananaw. That is 100 o 30. Munang 70. Lahi akong pananaw. The Y component of member AD is 30. Ay, sabot mo ani, no? Then, one na mo ani, it is better to tabulate all the data. Tabulate ninyo ang data kay para mas easier for you to look. So again, humana mo sa bar forces, wala pa di ay. So you have here negative 70 sa member DC sa vertical component. So I need to determine the X component. So I have to multiply 70 times 6 divided by 4. So munang 105. Then 105 times 2 square root of 13 divided by 6. So I have 16. So akong i-check diri sa ako ang C. So kinahanglan mo balance siya. So 70 compression, and sa imong component sa DC, it is also compression, negative 70. So balance na siya. Diri pod sa imong X, tension ang member BD. So sa imong member DC, that is also compression. So balance. So okay, balance na siya. So mao na to. Then again, for the unit load, asa to gipangita ang deflection to ninyo ibutang ang 1 unit load. So this is a symmetrical. So for symmetrical, only one side ang imuhang isolve. So you have there 0.5 for the reaction, 0.5. So again, this all, i-balance ninyong kada joint. So sa joint A, makita nimo, you have the X and Y component of your member AD. Okay, so paon nimo ang y. So your y is 0.5. So y nimo is 0.5. So 0.5 po diri sa y component sa member AD. Then, the same process, negative 0.5 times 6 divided by 4, so that is 0.75. Then 0.75 times square root of 13 times 2 divided by 6, that is negative 0.901. So, ibasa ninyo tanan. So, no? I hope nakakuha mo, ana. Okay, so, human na to is we have to tabulate. Okay, we have to tabulate. So, here, this is the tabulation. So, i-tabulate ninyo ang member, ang stress, ang unit load, ang area. So, this is the deflection. Because deflection at B is the summation of the deflection of each member. You take note the direction or the positive and the negative because it denotes the direction. You have to take note everything. I-tabulate nimo. So the answer there is 44.16. Okay, so any question? So at least nahuman na to 9 minutes before 8. Yes, dili na kaayo mo maadugay. Okay, any question? Kuha ra ninyo? Pasabot ra mo.
Deflection sa lain nga point, ma'am. But nga po 1 dito, ma'am.
Kung asa tong gipangita nga deflection, dito tong butang og 1 unit load. Okay? Okay. Nakasabot mo? So, maura ni ang mo ganito, ako tanong ipatry ninyo tong inyong trust kato akong assignment, pero indeterminate B mang puno to. So, dili pa mo ka-solve ato.
Ato ikaduha, determinate. Katong square ba?
Katong square, determinate.
Indeterminate.
Ang tanan?
Ang
Katong
kato
square,
lang
ma'am.
square. Indeterminate,
Ang
ma'am.
kaduha.
Ingon sila man good, indeterminate. Ako tani pa sa yun. So, kung mo skip mo sulay, di mo sulay. So, kamura dya po yung maglisod. Kani ba? Kana siya. I-determine ko na.
Ah?
Indeterminate. Kani.
Redundant, ma'am, sa tunga.
So, duwa ni ang pareha puro na sa indeterminate.
Oo, ma'am.
Oh, so, dili pa mo ka-solve. So, this meeting, I will give you an example for solving the indeterminate thing. At least nakakuha na mo, check na mo sa degree of determinacy. So, then, one input lang ng bar force. So, usara na siya ka-input. What you need to is you also have to apply 1 unit load. Sa indeterminate beam, i-identify na to sa ang redundant na member. Either member or function. Okay? So, sabot mo. So, ang kuan lang ani, asa man ang critical ani. Ang critical ani is the stresses, no? Stresses ra jud ang kuan kay ang is pag-tabulate okay naman. Ang kuha ra sa bar forces, mao ra siya. Bar forces due to actual load and bar forces due to kuan kanang unit load, or the stress due to actual load and the stress due to 1 unit vertical load. Okay, naka-screenshots na mo, class? So, wala na question? Okay, mo out na ko ninyo. Enough na for tonight. This one is sample kay kabalo ko inyo pa ning i-review. Okay, class?
Okay, ma'am. Amora.
Oh, sige.
Okay,
So,
ma'am.
nakakuha na mo, screenshot na mo. Sige, bye-bye. Okay, thank you.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Camping mo, class.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Okay,
ma'am.
ma'am.
Okay, bye.
Katong sa exam sa hydraulics, ma'am. Kay karon tong Friday, ma'am, no? Or next Friday, ma'am.
Karon nga Friday.
Akon nga Friday, ma'am. Yes, ma'am.
Oo.
Unsay nga
That's-
cover jatong last karon nga exam, ma'am?
Kuan. From non-uniform flow until hydraulic jump.
Hydraulic jump.
Mm-mm.
Then si Yuri, ma'am. Nato, ma'am. Wala pa, ma'am.
Wala pa ako
Sige,
ka-decide.
ma'am.
Kay
Okay
kamo
na, ma'am.
akong pa-decide doon. Wala pa ako ka-decide. So, the next exam will be frames. Frames, side sway, and without side sway. So, wala pa ko kakuan kung kanos. Maybe next week ang atong exam sa frames.
Sige,
That's
ma'am.
last exam. Okay? Sa side sway of okay?
Okay, ma'am. Thank you kay ma'am.
Kaya
Okay,
nga
ma'am.
akong
Thank
gikuan
you,
ang
ma'am.
oras man. Sige. Okay, bye-bye. Amping mo.
Thank you,
Bye,
ma'am.
ma'am.
Thank you, ma'am. Good night.
Good night. Nauna ka. Ate sayo-sayo taron makakaon.
Thank you, ma'am.
Gutom na, ma'am.
Good.
Yes, good, ma'am.
Kasayo-sayo taron. Sige, i-review niyo to ha.